hand. All right, this is a video on finding inverse functions. We're going to start out, we're going to do 4 or 5 problems here, and you can follow these step by step. You can also look at this video when you're at home. The first step in any finding inverse function is to change the function notation to a y. So we have y equals x minus 1. The next step is to switch the x and y. So we have x equals y minus 1. The next step is what changes for every single function. The next step is solve for y. So this is where the algebraic solving process comes in, where you perform inverse operations to isolate the y variable. This particular one takes one step, and that is to add 1 to both sides of the equation for y equals x plus 1. You have now done all the math part, and you need to take this and put it back into inverse notation, and your final answer is the inverse of g of x is x plus 1. Now, realize that with some functions, you're going to be able to look and tell. It makes sense that the inverse of x minus 1 is x plus 1. So that is why with multiple choice, or even if this is what you see, if you know the steps and you can visualize those steps, you know what you're working towards, and you can be confident in your final answer. Next, we have a function where the variable is in the denominator. Those functions are not as easy to just see. So most of the time, you have to actually work these out because the denominator has the variable originally. So first step is to change that to y equals 2 over n minus 1. And then in this case, if it makes you feel better, you can change that n to an x, but if not, just leave it and switch the variables. Switch the variables, and we're going to be solving for y, but now we're going to have n equals 2 over y minus 1. Now, it doesn't matter what's in this denominator. The first step in solving this algebraic equation is to get rid of the denominator. And the way that we do that is to multiply both sides of the equation by the denominator, whatever it may be. In this case, it is y minus 1. Multiplying the left-hand side of the equation by y minus 1 gives you n times y minus 1. Multiplying the right-hand side of the equation by y minus 1, because it's the denominator, cancels out, and you're left with 2. Keeping in mind that you're still solving for y, you have to work your way in to y. You cannot add 1 yet because you haven't gotten rid of these parentheses. So the next step in this problem is to divide by n. When you divide by n, you have y minus 1 equals 2 over n, because you've divided both sides of the equation by n. Think, even though y minus 1 might look like what you want to do something with, if you do something with it, it's just going to make this uglier. And so you have to think about this n times y minus 1 as 2 values that are being multiplied by each other. You're trying to isolate the y, so the best thing to do is to divide by the n. Now, the last step in this one is to add 1 to both sides, and your answer is 2n plus 1. And that's your final answer. Now, comparing the original function to its inverse in this situation is not as nicely done as the first one, because it was just one step. And notice this one took 3 steps to solve it. So working through those steps in your visual whiteboard is not the same as working through 1 or 2 steps in your visual whiteboard. So you're going to have to write some things down. In class, I'll come back to this if you have questions. For the case of the video, I'm going to keep on going for the problems. The next problem that we'll do also has the denominator with the variable, but it has even more going on. Still, your first step is to change that function notation to y, and then begin your problem-solving process by flipping the x and the y. In this situation, every situation, like I said, is different. So you have to look at this situation and you think, well, what would be the most logical thing for me to do so that I can begin to isolate y, to get y by itself? And in this case, I want to get rid of this plus 1 because it's not attached to the y yet. It's not grouped with the y. So I'm going to get rid of or inverse that plus 1 and subtract 1 from both sides of the equation, leaving me with x minus 1 on the left-hand side and 3 times y plus 1, or 3 over y plus 1 on the right-hand side. So you can't always say that the first thing you're going to do is get rid of the denominator if there's something else being added to it off to the side. Everyone is different. And everything that you can think of to do would be okay as long as you do it to every single term, but there are just some things to do that are better choices. At this point, we need to multiply both sides of the equation by the denominator, which is y plus 1. So on the right-hand side, I'm sorry, can't tell my right from my left. On the left-hand side, we have x minus 1 times y plus 1. And on the right-hand side, because I'm multiplying it by the denominator cancels out and I'm left with 3. Now at this point, you have the opportunity to make a terrible choice. And a terrible choice at this point would be to do the binomial multiplication and multiply this out. That would be a horrible choice because you need to think of each one of these as separate expressions. And if we have two separate expressions that are being multiplied by each other, to solve and get to the y, which is what I want to isolate, I can divide by x minus 1 because it represents one expression. If I divide by x minus 1 on this side, of course I'm going to do it over here, and these x minus 1s cancel out. So I'm showing that to you on this one so that you can understand that, yes, this is one expression, just as if it was a 5. You're left with y plus 1, and on the right-hand side, you have 3 over x minus 1. And your last step is to subtract 1 from both sides, and you have y equals 3 over x minus 1, and then minus 1. Those terms cannot be combined in any way. So this means that you've finished because you've isolated y, and the inverse function is 3 over x minus 1 minus 1. The last example that we'll do in this video is h of x equals the cubed root of x plus 2 and then plus 2. Our first step again is to change this function notation, change that h of x to a y. Now exchange y and x. And solve for y. The first step in solving for y, the square root acts like parentheses where you have to get to it first. You have to eliminate anything that's outside of the grouping where that variable is that you're trying to solve for. So the first step here, you should be thinking subtract 2. When you subtract 2 from the left-hand side, you have x minus 2, and when you subtract 2 from the right-hand side, you have simplified that side so that it looks like cubed root of y plus 2, which is what you want to do because you're trying to zero in on or hit that y. You're trying to isolate that y variable. Now we need to get rid of this cubed root. This cubed root has acted like a grouping symbol so far, And now I need to get rid of or inverse that cubed root. And the way we do that is to cube both sides of the equation. Therefore, we have x minus 2, that entire side, the right-hand side, cubed equals y plus 2. Because cubing that side of the equation takes away the cubed root sign. The last step here is to subtract 2 from both sides of the equation, and you have y equals x minus 2 cubed minus 2. The thing to remember, or another thing to remember, because there are so many things to remember, is don't make terrible mistakes like thinking that you have to multiply things out. Your goal is to isolate the variable y, and then to rearrange or rewrite this so that it is an inverse function notation, or in inverse function notation. So you would rewrite it here as x minus 2 cubed minus 2. Now this one, you may be able to pick up on some patterns that you'll see because the variable is not in the denominator. Notice that instead of cube root, our inverse function has a cube. And instead of plus 2, when it's grouped with the x, we have a minus 2. And instead of a plus 2 on the end, we have a minus 2 here. So there are things that you can look for to see if each action that happens in the original function has been reversed in the inverse function. So there's inverse functions and solving inverse functions. And just for the sake of those who are out of class, I'll see you in class.